Okay, so we're going to solve the second question now. So unlike the first one where we had the raw data, this is already simplified for us. In the first one, we had to calculate the sample mean and we had to calculate the sample standard deviation. But in this question, we already have those values. So over here, it says the average salary for American college graduate was this amount, 43,800. You suspect that that average is less. So this is the hypothesis that it is 43,800. And then the question in here is that it may be less. Okay, so from this first statement, you can get your hypothesis. The null hypothesis here will be that the average salary is 43,800, right? Sorry, excuse me. And the alternative, of course, will be that you are suspecting that it is less than that amount. Okay. So if you put in these values here to answer the question, the first one, okay, let's start from the first one. The first one says, what study do we conduct? Again, remember, if the population standard deviation is known, okay, population standard deviation, if it is known, then you're doing a z-test, right? But if population standard deviation is not known, is unknown, you are doing a t-test, okay? So in reality, we often do a t-test. There are rare cases where we do a z-test. So again, here, the population standard deviation is not known. We know the average. So a random sample of 56 students was selected and their salary was average. We found out that the average salary from that 56 students was 43,037, like slightly less than the population average, right? Okay, so this is a sample average, 43,037, and we know the standard deviation, but this is sample standard deviation. If it were to be population, you would have said population here, but it just says standard deviation. So we know this sample standard deviation. So for all this reason, we're going to be using a t-test. So the answer here will be t-test. Okay. For question B, it says the null and alternative hypothesis. I already explained that over here, so we can put them in. So here will be that the mean is equal to, the null will always have equality sign, is equal to 43,800. Okay, remember what goes in here is the population mean, not the sample mean. That's what goes into your hypothesis statement. So the second one, the alternative, again, we select that the mean. This question says less than, right? It says you are suspecting that it's less. So our value here will be less than 43,800. Okay. So we've answered question A and B. We go to question C. Question C says, what is the test statistics? So again, we know that the test statistics, because we agree we're going to use T, is given as the sample mean minus the population mean divided by sample standard deviation all over square root of n. Okay, so fortunately, we all have this value, unlike the first question where we had to work them out. So over here, we pick up the sample mean here is 43,037. So over here, we write 43,037 minus the population mean, which is 43,800, divided by the sample standard deviation. We can see over there is 11,310 all over the square root of sample size. And we know that 50, let's confirm that to be sure. We know that 56 students were sampled. So we have this to be square root of 56. Okay. So we use the calculator very quickly, and I will do this separately, like do the numerator separately and do the denominator separately. So that way we don't make mistakes. So let's start with the denominator. Okay, I'm going to use my calculator here to be quicker. So first I have the square root of 56, and that is 7.4833 and so on, right? So I'm going to divide 11,310 by the square root of 56, and my answer is 11. Oh, sorry, not 11. Just delete that quickly. My answer is 1511 points. So I'm going to get up to 4 decimal places, 3623, right? And the numerator is 43,037 minus 43,800. We got negative 763. Okay, so if you divide this up, you get your test statistics. Hope our work is correct. Just a moment. Okay, so if we divide this up, we got our test statistics to be negative 763 divided by 1511.3623. We're gonna get negative negative 0.5048. Okay, so if we run this to 3 decimal places as the question indicated, then we have negative 0.505, right? And that agrees with our test statistics. So our test statistics is negative 0.505. And mind you, the test statistics could be anything, positive or negative, right? It doesn't always have to be negative. It doesn't have to be small number, right? So remember what you are doing. If I should pull up a second page to explain that a little bit, not that page. Okay, let's use this one. Remember what you are doing. Better next page. Okay, so remember your test statistics here is simply you're looking at a T distribution. Draw. So this is your T distribution. Okay, I think the mouse is interfering with the drawing pad. Okay, so this is your T distribution. I've got the middle is 0, so you have positive 1, 2, 3, 4, and so on. And so you have negative 1, negative 2, negative 3, and so on, right? So your t-test statistics or z-test statistics could be any of these numbers, okay? So, but remember in this example, we are doing a left tail, so it makes sense that our answer should be negative. Okay, so let's go back to that very quickly and continue. So our t-test statistics is 0.505. And the next is to compute the p-value. And we go back to our Excel. Remember, for the p-value, you're supposed to use t.dist dot 2t if you are doing a two-tail test, right? But remember, in this case, we're not doing two tails. So you have another function that t.dist dot rt standing for right tail, right? So this is used when you're doing one tail. Okay, so whether this one tail is left tail or it is right tail, it doesn't matter. You use the same function to compute it, right? By the way, remember in the function, you always put in a positive value. So, and again, the reason why the two answers should be the same, if we go back to our explanation again, is if I'm doing a left tail, and let's pick up a different color to illustrate that. So if I have my red here, if I'm doing a left tail over here, right? So if I go into the system, and so this is my area, indicating the p-value here. And this is my test statistics, negative 0.505. The equivalent of a right tail for this will be the same shape, but my shaded area will be on the right tail, right? So if I pick the same value, but the positive one, 0.505, we saw earlier that the p-value, this shaded area, will be equal. You know, if you start from the same point and shade to your right, you are getting the same thing. Yeah, so if your test statistic just switches sign, the area they cover to the tail will be equal. Okay, so let's go back to the question. We are going to be using, and if I should pick up, let's pick up a different color to highlight this. Let's pick up red. So we're going to be using this function because we are doing one tail. So whether you're doing left or right, it doesn't matter. This function is for one tail, but if it's two tail, use the first one. Okay, so let's go to Excel now. We're trying to calculate the p-value. Pull up Excel. Okay. So on Excel, you just pick any cell, right? And let me make this bigger so you can see that better. Pick up any cell. This is equal to T dot this. As you're typing, it pops up. Remember, the one we are going to be using is the second one. So click on it, right? Double click really to insert it. And the first item you put in is your test statistics, right? So we got 0.505. And then our degree of freedom. We are looking at 56%. So our degree of freedom will be 55. Okay. Let me explain this again on the paper here. Okay, I think it's better we write it in on the actual worksheet over here. So remember that inside our function, right? Let me write with red. When you do t.dist, and because you're doing 1T, you do RT, the first thing you need is it's marked as X, but that is your test statistics. So you should have 5.050, the positive version there. And then you have your degree of freedom. Again, remember degree of freedom is n-1. And in this question, we have 56 students, right? So here, this will be 56 minus 1, which is 55, right? That's how we got those values. Then let's go back to the Excel and get the actual answer. So you put in your value, t.this, RT 0.505, 55, then press enter, and it gives you your p-value. So our p-value is 0.30779. So our p-value is 0.30779. Okay, so let's see. I didn't show the answer key here. Okay, it's shown there. Okay, so if you run this off to 4 decimal places as the question demanded, as for 4 decimal places, this will be approximately 0.3078. Okay, so that agrees with the answer here. That is your p-value. Then you go ahead and answer question E. Well, question E says compare the p-value with alpha. Okay. Of course, we see that p-value is bigger than alpha, isn't it? Alpha is given in the question, is always given in the question, right? You don't need to compute that. It's always given. And if it's not given, you are told indirectly how to get it. For example, if I give you the confidence interval, right? You know that alpha is equal to 1 minus confidence interval. So you can find alpha if you're given the confidence interval. So by one word or the other, the alpha is given either directly or indirectly through the confidence interval. So we know alpha to be 0.1. And if we compare the two, if you compare p-value with alpha, you see that p-value is bigger, of course. So 0.3078 is definitely bigger than alpha, which is 0.01, right? So your option here, what you put in there is greater than symbol. That's what you put in because it's big. Okay, so based on this answer, what do you do? Coincidentally, the answer aligned with the first one too. But pay attention that your decision is to reject when it is greater. Then let me show that again on the other page. And you can watch the class video to get more information on this. So for your p-value decision, when you compare p-value with alpha, okay, if p-value is bigger than alpha, then you're going to fail to reject the null hypothesis. Okay, if p-value is less than alpha, then you're going to reject the null hypothesis. Okay, we're going to repeat this again in class on Tuesday, but you can also watch the video for first one to see more explanation about the shaded area that is called the p-value. Okay, so over here, we will come here based on the answer in question E. For L, we are going to fail to reject because p-value is big. We fail to reject the null hypothesis. Of course, if you fail to reject the null hypothesis, it means you are supporting the, it means you are not supporting the alternative, right? So let's look at this first set of questions. From this conclusion, if we fail to reject the null hypothesis, it means we are not supporting the alternative. So let's look at the options and see which one aligns. It said the data suggests that the population mean is significantly less. No, it is the alternative that says, so let's write down here. H naught is that the mean is equal to 43,800. Okay, H1, the alternative, is that the mean is less than 43,800. Now we fail to reject the null, which says it's 43,800. So because of that, we are not supporting the alternative because we did not reject the null. Okay, so this first option says that the population mean is significantly less. That makes it wrong. Okay, let me pick up another column. Pick up green. So this is wrong because we did not reject the null, which says it's 43. So we can't say significantly less. So that is null. So we're actually looking for one that says not significantly less. Okay, so that leaves us with the last two options. So let's read. The data suggests that the sample mean is not significantly less than 43. That is correct because we fail to reject that is less than, that is equal to, right? So if we fail to reject that is equal to, it means it is not different. So it's not significantly less than 43,800, right? At the given alpha. So there is statistically insignificant evidence to conclude that the sample mean salary for graduates from your college is less than that. Okay, so that sounds correct to me, but let's look at the last one and just be sure. Okay, the data suggests that the population mean is not significantly less. Okay, that is true. So there is statistically insignificant evidence to conclude that the population mean salary for graduate from your college is less than 43. Okay, so you see the trick here. The trick is in this value, because these two questions are the same. You just have this difference in these two values. So which one are we taking as the correct answer? Okay. Remember, your hypothesis statement is stated in terms of the population mean. That's what we use in these two formulas. So the values you're making reference to in your conclusion had to be the population value. So that makes this answer correct because this is a sample average. Okay, so the answer, correct answer here is this, because the hypothesis statement is made, H0 is saying the mu, the population mean, is equal to 43,800. And it's saying H1 is saying that the population mean is less than 43,800. So the null hypothesis is stated in terms of the population. So that makes the second answer, or the last answer, more correct. So these first two are wrong. Okay, so we have more question here. I think looking at the definition of p-value, and I'm going to include that definition on the slide as we stated in class. So over here, let's look at this. It says interpret the p-value in the context of this study. Okay, remember the p-value is 0.3078, something like that. Yeah, let's confirm that. Yeah, 0.3078, right? And so because it's an area, remember what the p-value is like, we're doing a left there, is this area that is equivalent to this value. So that is like 30%, 30.78%, okay? So let's read through the options and see which one is correct. It says, if population mean salary for graduates from your college is 43,800, and if another 56 graduates from your college are surveyed, then there will be 30.77, so it's 30.78% chance that the sample mean for these 56 graduates from your college will be less than 43,037. Right? Okay, so read the next one. If the population mean salary for graduates from your college is 43,800, and if another 56 graduates from your college are surveyed, then there will be a 30.78% chance approximately that population mean salary from your graduate college is less than this. So the difference between this question is that this is referencing population mean salary, and it uses the population mean salary here. But this other first one is referencing sample mean, and it's using sample mean salary here. Otherwise, every other part of this question, of this option, they are both the same. Okay, so which one is more correct? Okay, so pay attention to this. P-value, remember how p-value is gotten? P-value is gotten from your data, right? So if we go back to this question, I mean to this diagram here, let's do this very quickly. Okay, let me get to the next page. If we draw here, and if we're using the left tail, this is your alpha, chosen before the question is worked out. I think it's 1.0 here. This is alpha set before the question is started. Then you go ahead and collect your data, and let me use blue. You collect your data, and then you compute your test statistics from your data. You know the formula. T is equal to your sample mean, population mean given in the equation divided by sample standard deviation divided by solution. So you calculate the T statistic and you locate it along the continuum here, right? So this is the middle of your data. Since the value we got was negative, it was somewhere here. So this was negative 0.505. Okay. It is from this test statistics, which is coming from the data, that you got your p-value. Right? The alpha that you have here is giving you the critical value. That is the value that is here. So this is the critical value. Okay. So alpha gives you critical value. So this is referring to kind of preset decision, but your p-value is calculated from your test statistics. So, and the test statistics is gotten from the sample information, right? All right, so let's go back to that and finish up. So that the more correct answer here is the one that is referring to the sample. So the p-value refers to the sample, not the population, right? But hypothesis testing that we answered earlier, hypothesis testing refers to the population. Okay, so this is what gives you the guide to this answer. So why the first answer had to make reference to population and hypothesis testing, the second question on p-value, or the following question on p-value had to focus on the sample. So that first one is more correct. The rest are just a kind of different way of stating different things, but they are not defining p-value. This is the definition of p-value, okay, in practical sense. All right, so that is H. So again, this answer is wrong, this one is wrong, this one is wrong. The correct option is the first one. Let's go to the next question and the last one. Then we end this video. Okay, so the last question here is trying to also make you define significant level. Let's pick a different color. Trying to make us define significant level. Okay, that's what the question is trying to define, but in context of the study. Okay, so again, remember what the significant level is. Significant level is your alpha, right? And what is your alpha? If you remember from the class video, so you might go back and watch the class video to be able to understand that. We spent time explaining that. So alpha is something as your type 1 error. Okay, and what is your type 1 error? The type 1 error is the chance or the probability of rejecting the null hypothesis when in reality it is true. When in reality the null is true. Okay, so a chance of rejecting the null hypothesis when in reality that null hypothesis is true. Okay, so let's go through these questions and see which one matches. It says, if the population, so that is a mistake there. So if the population mean salary for graduates from your college is less than this, less than the population value 43,800, and if another 56 graduates from your college are surveyed, then their, alpha in this question is 0.1. Oh, I think it's 0.01. Let's confirm that very quickly. I think it's 0.01. So alpha in this question is 0.01 over here. Okay. So let's go back down. So alpha is 0.01, which is the same thing as 1%. Right? So let's continue reviewing the options. So the first one says, if the population mean salary for graduates from your college is less than 53,800, and if another 56 graduates from your college are surveyed, then there would be 1% chance that we would end up falsely concluding that the population mean salary of graduates from your college is equal to this value, right? Okay, so forcefully concluding is type 1 error, right? Okay, so forcefully concluding It's not the type 1 error. So look at it this way. So type 1 error will be rejecting the null hypothesis when it is true. Okay. So this question says, forcefully concluding that your college is, that the average salary is equal to that. So this is actually stating the null hypothesis, that the average salary is equal to 43,800. Okay. So this is saying forcefully concluding that the null is true. That is what this option is saying. That there is 1% chance that we forcefully conclude the null is true, right? Okay, so when you forcefully conclude that the null is true, it means you actually fail to reject the null. Right? That is what it will interpret. It will be interpreted as, right? If I forcefully conclude that the null is true, it means that I fail to reject the null, because that's why if the null is true, then I fail to reject it. Okay. But type 1 error had to do with when you reject the null. Let me use red to highlight that. Type 1 error had to do when it's related to rejecting the null. So if I fail to reject the null, then that is not what the type 1 error is. Okay, and type 1 error is alpha, and is alpha, which is significant level that this question is trying to define. So for that reason, this answer is wrong. Okay, because this is referring to failing to reject. That is what it means to conclude that the null is equal to the population value. Okay. And this is actually type 2 error that was described by the first option. So let's look at the second one and see how it aligns. It says, if the population mean salary for graduate from your college is 43,800, and if another 56 graduate from your college are surveyed, then there will be 1% chance that we would end up forcefully concluding that the population mean salary for the graduate from your college is less than 43. So let's look at that. Forcefully, so this is actually stating the alternative. Right? Forcefully concluding that H1 is that the mean salary is less than 43,800. Okay, so this is the alternative hypothesis. So to forcefully conclude that the alternative hypothesis is true means you rejected the null. Because if you reject the null, then you will conclude that the alternative is true. But it is an error because we forcefully concluded that the alternative is true. So which means we rejected the null hypothesis, we rejected H0. Okay, so, and this is exactly the definition of type 1 error. Type 1 error is to reject H0 when it is true. So to wrongly reject H0 is your type 1 error. Okay, so that makes this the correct answer. The rest are stating, the same thing in different ways. So you can go through that also and see that is not what type 1. That is not what significant value is. Okay, the definition you have in the last two options. So the second option is more correct. Okay, so this will come with practice. But you have like 2 questions on the homework to practice some of these things here. Okay, so we're gonna stop here. What you do is, I know these things are kind of a little bit tedious. What you do is simply I think I should share my screen while I talk through that. What you do is to walk through these homework questions and send me, if you're not getting the answer right after trying maybe 2 or 3 times. You don't have to try so many times, right? After doing it 2 or 3 times, watch the video, do it 2 or 3 times. If you're not getting the answer right, send me a screenshot of your solution. Work it out on a piece of paper. Send me a screenshot of your solution and send me a screenshot of the question you're trying to solve, right? So when I get these 2, I will be able to give you specific feedback. But we'll walk through all this on Monday, but I hope that with these 2 videos, you are able to get started on the homework. And then when we meet on Tuesday, rather, we'll walk through these things again, okay? I will see you.